be taking you through how to install your local instance on Windows, and this is a big win for us as we continuously continue to improve our resources so that they can accommodate all types of operating systems. So it's ideal for users who develop once in a while, and you'll see why maybe it's once in a while, and people who'd like to learn a little bit more about CHT configuration. So the pros are that you only need to use VS Code dev containers, which will allow you to install and develop without installing all the other dependencies. And then it's also really space friendly. You don't have to have WSL. You just need to have a few prerequisites. The only con is that you have to download the dev container.json file each time or for each project directory that you're going to be using. Do a little demo just to show how you'll do this installation. Feel free to stop me in case you have any question. And I'll walk through the demo. So we have documentation on the doc site on how you can develop with VS Code dev containers. And all you'll need is to install Docker Desktop, you'll need to install Git Bash and Visual Studio Code. So those are the only 3 things that you need in terms of resources. So just ensure you have Docker Desktop, and I'm just showing that there are no containers running for now so that we can see the progress as we continue. Yeah, so we don't have any containers running for now. It's completely new. So once you install Docker Desktop, this is what you'll be able to see. And then we use Git Bash. So this installation is specific for what I'm showing right now, is specific for Windows. So initially, Windows users were having a hard time installing. They needed to install so many dependencies. So we use Git Bash so that we're able to write the curl commands, and we're able to download a TLS certificate that you'll see later. And then you'll need Visual Studio Code because, as I said, we're going to be using dev containers to be able to install the local instance. And all this is highlighted in the documentation. So also on the documentation, it gives you a link to directly go in and download VS Code for Windows. So really easy guide to how you can do this. You don't have to be very technical to do it. And then we have Git Bash here. So the first thing I'm going to be doing is creating a CHT project directory. It's going to be a completely empty project directory. So I'm creating it on the desktop, and we can see it there. So once you create that directory, you go into the directory so that you're able to install the dev container extension within that directory. So that's the only con with this way of installation. You have to do it for every project directory, but it's very easy. You just need these 3 commands and you're good to go. So we copy and paste them inside that directory. So once you do that, it will open VS Code and ask you to reopen that directory inside our container. So we are going to be doing all our CHT commands inside that container because remember, we don't have dependencies outside this container. So if you run any CHT commands outside the container, you'll get an error. So it will take some time to open the dev container. And once you have this, so you can see the terminal is different. And we also have now a container running inside Docker Desktop. So the terminal is different because we are now going to be developing within the container. And if you look through your extensions inside the VS Code, you'll see that dev containers the extension dev containers has been installed using the command that we ran, those 3 commands that we ran initially. So we've created the CHT project directory, the extension has been created, and now we'll initialize project directory Remember, we are only running CHT commands within the dev container, and we're using VS Code. So you copy that so that we're able to initialize the project layout. As you can see now, CHT project is empty, but once we run this project layout, we can see the framework of what CHT projects usually look like. But they're completely empty for now, empty forms, empty privacy policies. So you can do your own configurations by yourself. So once you're done initializing your project, we go ahead and now we want to run our CHT local instance so that we're able to see it on the browser. So we'll do this using Docker helper. And the first thing you need to do is clone CHT core because we're going to run the Docker helper script within CHT core. So it's pretty easy. This is also highlighted within the doc site. If you already have CHT core, you'll need to git pull origin so that you have the latest CHT core. So once we've done that, we'll run the .sh file so that we're able to run the script. That's within CHT core, within wherever it is that you'll find Docker helper 4x if you're running 4x, or 3x within CHT, your CHT core directory. So we are going to initialize a new project and we're just going to call it roundup call October. It will take some time. So the first time it will take some time to download the compose files, but anytime after that, it's pretty easy. So you've seen it's been quick and you're given a URL there that you can use to access your local instance. So you paste this on the browser and you're able to log in with your username and your password. So you're able to log into your local instance. As you can see in the local instance now, I am able to create a new health facility there. And once we go back to app management, I only have one user and I have a couple of forms there. So these are the forms that come, default forms that usually come with CHT core, and you're able to upload any other forms that you require from your project directory, and we're going to see that. So to push your project content from your local machine to your local instance, you can see here our URL has 127.0.0.1. So that's our callback URL. And we need to, it's not our real IP, and we need to change this so that we're able to push it to our local instance. So this is something that Mr. Jones is working on. It's just something that we are trying to fix. So we are working very hard to ensure that we don't have to go on and look for your real IP for your machine, that you're able to, that Docker helper is able to just push this URL for you. So you've seen it's given us an error because we are using a callback URL. So we go ahead and find out what the real IP for our machine is. And to do that, we just type ipconfig on our terminal, which is very easy. You don't have to be technical to do this. So you go ahead where IP version 4 address is, that is where your URL, your IP is. So you just copy that, replace what was 127.0.0.1 with this URL because this is the real one for your machine. Hopefully this will be able to be fixed. So we go ahead and just change that. So the port remains the same. You can see at the very end, it's 10.4.4.5. So that remains the same. We copy this. So we are going to be running CHT commands with this command that we have here that I've just copied. And we're going to paste this with our terminal in VS Code. Remember, we are pushing CHT project, which was a completely blank project directory. We just have the framework, the layout, because the only thing we did was initialize project. So once you go back, it's updated you that there's an update available, you reload, And you can see we don't have create new health facility as we did before, because it's completely blank. We don't have contact forms, we don't have app forms. And once you go back to app management, you'll be able to confirm the same. In app forms, it's completely empty. So you have successfully uploaded a project from your local machine to your local instance.
There's a question in the chat which asks, is this for CHT Core version 4 or could it work with CHT version 3X? And there is a version, I'll go ahead and answer that. There is a version of Docker Helper which does work with 3X, and that should work on Windows, which is covered in our documentation. When you're on the application developer installation page, at the top there'll be a link to doing the same task in 3X. Otherwise, the workflow will be the same, such that you'll use the VS Code container and you'll use CHT-conf inside VS Code to push to the URL, except the URL will be to a 3X instance. So the only thing that's different is the Docker helper steps. And if you get stuck, please post in the forums. We'd love to help you debug that.
Yeah, so I'll be giving an update on product ecosystems. I'll combine that with the CHT Academy update as well. So we can move on to the next slide. Yeah, so for CHT Sync, this is something we've been working on since Q3. So a big update here is that we decided to continue working on CHT Sync and added a couple of OKRs on our roadmap just to suit this. So we are, in addition to the production dashboard that we are currently finishing up working on for one of our projects, we are looking into having this CHT Sync deployed nationally. That's in line with our goals. So what you're looking at is having dashboards consume data of the CHT Sync configuration that are couched to PG, and this will be done. It will be done this quarter. Probably have it in production by early Q4. And then of these two deployments in production, we are looking to document our learnings of CHT Sync and CHT Pipeline. So that would mean that anyone can actually pick this up and deploy CHT Sync in their environments. The thing about this is you can also just deploy it on any version. Doesn't matter the version of the CHT you're using, since it's only a way of copying documents from CouchDB over to Postgres, just to have it pulled by the dashboards that we are working on. So ideally, we work with Superset since it's open source. However, for one of these production dashboards, we'll be looking into Portfolio, since the dashboards are already being created and they pick data off Postgres. So the data will just have it being picked up by Portfolio rather than Superset, but that is also to show that it doesn't really matter the platform you choose for your dashboards. You could choose any platform and it will still work. Yeah, so that's where we currently are, and we're just finishing up on the modeling of the data and have this data being pulled by the dashboard. In this case, it will be Portfolio rather than Superset. Next one is on the Academy update. So for interoperability, we showcased our work, the reference application, in the September OpenHI implementers call. It was quite successful. There's a link there. I am sure the community team will share the slides here. You can see you can watch the video. We got quite some good engagements there. And yeah, you're welcome to review our repo. All those things are shared will be shared with as we share the slides for this call. So the big update is that we are launching the interop course, which we've been working on in Q3. We are hoping that it is in line with one of our OKRs for the quarter. This would mean that you're able to just take our reference application build your own mediators and just use their work and make it easier for you to work with other systems. So I'll just have a brief demo on how this looks like. So I'll just share my screen. There it is. So we have a course on interoperability. So as you can see, we have a couple of modules here. We have about 5 modules. In each module, the structure is that you will learn, get to do an exercise, and then there's a quiz there. And then at the end of it, there will be a certificate that will be provided to you. So the first module is on just an introduction on interop, why we did it, why it's important, and the vision that we have for this. So as medic, we'd like to have the CHT, the system that we steward, interoperating or exchanging data with other external systems. And this module just talk about that. And then from module 2 all the way to module 5, it gets a bit technical. We talk about the standards that we use in module 2. We have about 5 topics there. We talk about the standards and a local setup. And then we can talk about the fire standard itself. Then we have OpenHIM. OpenHIM is the middleware that the CHT communicates with the system through. And we have an assignment, summary there, and the quiz. And then as our proof of concept was the loss to follow-up workflow. So here, it's part of the complete referral workflow. So here, if a patient misses an appointment, an EMR will raise a list of these patients, and then these patients ideally will appear on the CHT as tasks. So these tasks we need to follow up either on phone or call or visit or do something on just visit the patient, and then you can actually update on the CHT, and then it goes back all the way to the external system, could be an EMR. So here you have the introduction to that. You can set that up. So setting up this means setting up an external system. So for us, we're using an API testing tool, which is Postman. And then I have a walkthrough of the loss to follow-up workflow, do assignment, and then your quizzes. The second last one is on automated testing, how we did our end-to-end tests. So you run a few scripts there, and then you're able to just create all the containers and destroy them as you confirm that they're actually working. The last one is on how we built our mediators. So this we have about 5 resources. So you'll see 5 resources. You'll see how that is utilized. And then yeah. So how we do the mediators? This one's a little bit long. It could be about if you spend some time there, could be like about 30 minutes. Just learning on this, and then there's an assignment there and a quiz as well. So that's it for the interop course. The announcement is after this. Please register. It's open for anyone to just get into it and learn more about interoperability and the work and use this reference application to interoperate your other external systems with the CHT.
I'm Ashley Jones. I'm a technical product owner based in the United States, and I have an update on Watchdog today. So I'm going to go ahead and share my screen. So we had a recent outage in a production instance, and I wanted to kind of walk that back on how we were able to monitor that, detect it, and then successfully see that a upgrade had really helped it. So it's important when you think about monitoring and alerting that you don't try to deploy it when you're in the middle of an outage, because then you won't know how it works. You'll be rushing to do it. So I realized one of the key reasons we succeeded is that we deployed Watchdog in this scenario at the time that we launched the instance. So that way it was already monitoring everything, and we had baseline metrics for everything so that we knew when the Sentinel backlog increased that it was abnormal. It wasn't something that we would expect, like on a nightly schedule or on a weekend when there's lots of activity for CHW syncing. As well, we took time to learn the different metrics that were inside the watchdog. So we knew what the MEDIC database growth meant versus the user database growth, or again, like what those Sentinel backlogs were meaning as we saw those spikes in activity. And you can use it to not only, as I mentioned, detect outages, but also detect successful upgrades. So I have a demo here that I'd like to give that shows how you can take data from one panel to another and really benefit from the different data that you're gathering. So here's a watchdog instance. It's against our a test instance that we run internally at MEDIC, and you can see clearly that it's down. And so we might look over in the admin details and see that the document growth in the MEDIC database has stopped, and that it hasn't grown that much. It's just grown from 90 to 94. We would expect these numbers to be larger in a production instance. But if you'd like to correlate this graph with what's happening over on the API server, you may want to see some of these graphs side by side to try to line them up. So a key feature of Grafana is that any panel you have can be copied from one dashboard to another. Now, all these dashboards come pre-configured on Watchdog, so everything you see just works like this out of the box. But like I said, you may want to see something side by side. So what I'm going to do is go ahead and take this request per second, which represents all the CHWs trying to synchronize to the CHT, and I'm going to go ahead and copy this. And then I'm going to go back to the other panel that has the database growth, and I'm just going to paste that in. So what I've done, oh, there's no data here. That must be an error. What I've done is I've added this panel, and as you can see, I can resize things and kind of line things up to try to get the data in a alignment that allows me to see the correlation of events between panels. And as I mentioned, these are already shipping pre-configured from Watchdog. So any changes you make won't actually be saved, and that's intentional because as these dashboards get updated, we're going to want to be able to have you do a git pull to get the latest updates of the dashboards. So when I reload this page, it's going to prompt me, are you sure you're going to leave? And you'll see that all the dashboards are reset. So this is an encouragement for you to explore and drag things around and copy things and get the data just as you'd like to try to debug what happened and to appreciate how data can change over time. So that's just a demo that I wanted to give that shows the flexibility of it. And then I want to go back to the presentation and talk about this slide here. So what you're looking at is 3 panels. At the top, you have the document count. In the middle, you have the Sentinel backlog. And on the bottom, you have the doc count for the Sentinel database. And what you have highlighted is 4 red rectangles with frowny faces. And what the frowny faces represent is a massive spike in Sentinel backlog. Note that the scale is in 5,000 increments. A diurnal spike or diurnal growth for every day that there's activity. And then most importantly, the gap represents an alert that was fired in Watchdog, denoting that the API server had become unavailable and that CHWs were unable to synchronize. And this persisted for 4 days. And you can see that there's a direct correlation between the slope of the database growth and the spike in Sentinel backlog, which means that the more that documents that the CHWs were uploading, the harder it was for Sentinel to keep up. And then what happened right here is that we upgraded to CHT 4.4. And CHT 4.4, well, actually, we went from 4.2 to 4.4, and CHT 4.3 has the Nairobi protocol, which greatly improves synchronizing day to day. And I believe it was CHT for one that has a massive improvement in initial synchronizing. So here you can see that we're happy. We have the same database growth, but we don't have any spike in Sentinel, and we don't have any of the gaps denoting there was an outage. One more graph. This is the same data, right? So we have the doc count and the Sentinel backlog, and now we're looking over a greater period of time. And so we can, again, see the growth going up, denoting that we have active users, but we can mark in time, and I'm just kind of taking screenshots and using my screenshot tool to mark this up and say, this is when we upgraded. And on the left, you can see the Sentinel backlog spikes. You can see the API outages. And on the right, you continue to see database growth showing that it's being used. And while we do have